Hi everyone. In the last class, we learnt about control statements. In today's class, it's about loops or iterative statements. So what are these loops and iterative statements? As I told you in the last class, in the entire programming, control statements and loops are the heart of programming. So if you understand these two, it's as good as knowing 30% of coding. If you grasp these two, then yesterday in control statements, we learnt about if else, nested if, else if ladder, and switch. We covered these concepts. Today in loops, we will learn about for loop, while loop, and do while loop. So what exactly are these loops? Basically, if you want to execute a particular code or a particular block repeatedly, in situations where we need to execute something multiple times, we use loops. Now, for example, suppose I want to print my name, see out, Raj. So I want to print this name. Now, to print this name, this one line is enough. But suppose I want to print this name 10 times. What will I write? See out, Raj, see out, Raj. So, like this, I would have to write it multiple times. But I won't write it like that. If I want to write a particular logic only once but execute it multiple times, in such situations, we use loops. How do we execute that? I will show you with examples. So, coming to the for loop, there are three parts. The first part is initialization. The part 2 is condition. The part 3 is operation, that is, it can be increment or decrement. In a for loop, there will be initialization, condition, and operation. The operation can be increment or decrement. There are three parts. What these loops mean is any loop, for loop, is used to repeat a block of code for a specific number of times. To execute a block of code for a specific number of times, we use a loop. The for loop executes in one style, the while loop executes in another style, and the do while loop executes in its own style. So, before understanding how each loop works, let's go to the for loop. Let's see how this for loop executes. For example, suppose I want to print some numbers. Like, suppose I want to print 1 to 5 numbers. How do we print these? See out, 1, see out, 2, see out, 3, see out, 4, see out 5. Like this we print. So, but now I want to use loops. I don't want to print like this. If I write the same program using loops, for instance, I is equal to 1, it less than 6. If less plus, if I write the same program using a for loop, what I can do here is see out I. So here, instead of writing a block of code 5 times, the same code, to print these 5 numbers, I had to write it 5 times. See out. But here, I wrote it only once. What I did was, I put that particular part inside a block and wrote a loop. Now what happens is, as I told you, there are three parts here. This is the initialization. This was initialization. This was condition. This is operation. Let's see how these work. Now, when I say I equals 1, a variable is created. What is its value? 1. Now, 1 less than 6, true or false? 2. Whenever the condition becomes true. See, whether it is control statements or flow and iterative statements, everything works based on that. That means it works based on the condition we give. Now, suppose there is an if condition. If suppose I is less than 6, if this is true, it will execute for one time. The difference between condition statements, that means control statements, And loops is that control statements execute only once when the condition is true. That's it, it's done. But coming to loops, when it comes to loops, as long as the condition is true, it will execute multiple times. That's loops for you. A condition statement will execute that block only once. But when it comes to loops, they execute multiple times. That is the only difference. The remaining parts are exactly the same. The block will execute only if the same condition is true. It executes just a single time. Control state to be executed multiple times. That means loops simply now I 1 less than 6. For example, what happens when it is true? Cout I1 gets printed. Next, I plus plus. I plus plus means, as I told you while explaining operators, I equals I plus 1. This operation always happens inside the loop body. We call this the loop body, these brackets. The logic inside the block is called the body. After this block gets executed, this operation is invoked. Now what happened? It became 2. Now is 2 less than 6? That is true. Now what happens? 2 got printed. Now it became 3. 3 less than 6. Which is? Now 3 got printed. Now I is equal to 4. 4 less than 6. 4 got printed. I is equal to 5n. 5 less than 6. 5 got printed. I is equal to 6. 6 less than 6. False. So the loop exits whenever the condition fails. That is, when this condition becomes false. At that time, the loop, it breaks. That means it stops. So executing that body will stop. We can write these conditions in any way we like. We can write the condition as we wish. We can initialize as we like. We can perform any operation as we wish. This operation can be I plus plus, I minus, or any operation we prefer. We can write that. This is how it gets executed. Let us look at a sample program. So what exactly am I going to be doing in this program? I'm printing numbers from 1 to 10. I equals 1, I less than or equal to 10. You can also say I less than 11, or you can say I less than or equal to 10. I plus plus, cout I. Now I will show how this gets executed through an animation. See, I equals 1. I has been initiated with 1. I less than or equal to 10. True. Then I is printed. What is the value of I? 1. Next, I plus 1. Now the value of I has become 2. 2 less than 10. 2. So what will be the value of I now? 2 plus 1, I plus plus, it becomes 3. I plus plus, now what does it become? It becomes 4. The value of I is 4. 4 less than or equal to 10, true or false? True. 4 is less than 10. 4 is printed. Now the I value is 4 plus 1. 5. I plus plus. Again, 5 less than or equal to 10, which is true. It's happening now. This 5 is printed. Now I plus plus 6. How long will it print like this? 6 less than 10, 7 less than 10. Let's forward this video. 8 is printed, 9 is printed, 10 is also printed. Now 10 plus 1, 11. Is 11 less than or equal to 10? True or false? The for loop has executed. That means this loop has executed 10 times. So to execute a logic multiple times, we use loops. Among them, the loop here is a for loop. In a for loop, there is initialization, condition, increment or decrement. This increment or decrement can be any operation. They will show you some examples. There are 10 examples in these loops. You have to do them using each loop. So in this one, I equals 1, I less than or equal to 10. This will print 1 to 10. So the output will be 1 to 10 printed. Now, if you look at the second question, what is this? How will it print? It will print 10 to 1. यार ऐसा नहीं है कि if you go back tomorrow, try one something. Now, if you observe the program, see here. Earlier, we wrote I equals 1. Now, I equals 10, I greater than or equal to 1, I minus minus. Let's play an animation video for this. Our intention, a loop always has an initialization, that is a starting point. Condition means the ending point, that is, it should keep moving until that condition becomes true. Operation means at what speed it moves or how we do it, we write that in the operation. Here, 10 got printed. Why? Because 10 greater than 1 is true, na? See, I minus minus, n minus 1, I equals 9. 9 greater than or equal to 1, true or false? 9, it got printed. I minus minus, 9 minus 1. Yeah. See, 8 greater than or equal to 1, true or false? So, this becomes a when minus minus becomes c equals to 10. It prints I minus minus 1 minus 1 0. 0 greater than or equal to 1, true or false? So false exit the loop. That means in this first example printing 1 to 1 0, in the second example printing 1 0 to 1. Now what is the third example? We have to print from minus 5 to 5. Simple. I equals minus 5. I less than or equal to 5. I plus plus. Then the second example. Now, if you want to print from 5 to minus 5, that means you have to use different greater than and less than with positive and negative numbers in the programs we write. Look here. If you want to print from minus 11 to 22, how will it be if you use a for loop? How will it be if you use a while loop? So, after executing the while loop, let's see the examples. For loop is clear to you, right? What is there in a for loop? Initialization, condition and operation. These are what are present in a for loop. So we have to specify all three in the for loop. Next, coming to the while loop. What are these while loops, you may ask? This also uses conditions. It checks the conditions and keeps iterating the loop as long as the condition is true. But in the while loop, the main difference between for loop and while loop is this. In a for loop, there are three parts: initialization, condition, operation. But when it comes to while loops, initialization is not my concern. Operation is not my concern. I will only take care about the condition. It is called a while loop. That means it is called entry control. Entry control means that only the condition is checked. Before entering the loop, only the condition is checked. So after that, based only on that condition, it will execute. No matter what else we write, it doesn't matter. It doesn't care about what initialization you have done or what operation you have performed. It will only take care of the condition. In what kind of situation do we use this? Any program that we write using a for loop can also be written using a while loop. Similarly, any program written with a while loop can be written with a for loop. So, which loop to choose and when, you'll understand as you go forward and solve hundreds of problems. Whenever you're solving a problem, you'll get clarity. Okay, in these situations, I should use a for loop. In these situations, I should use a while loop. And in these situations, I should use a do while loop. So, in the example I'm going to show you with the while loop here, look, I'm going to show you an example program. Now I am 1000. I have taken the number 1000 or I have taken the number 10,001. That number is greater than 0. Until it is done, I am performing an operation. See, here I can write just one line for the operation, or I can write multiple lines, even hundreds. What I write inside the loop is not specifically related to this while loop. It just takes care of whether the condition number greater than 0 is true or false. That's all. So in this animation video, you will clearly understand in what kind of situations I use the while loop. But is 1000. While number is greater than 0, that means is number greater than 0? Is 1000 greater than 0? Absolutely true. Then it'll enter into the loop. Any of our loops, whenever the condition is true, it will enter into the loop. Now, what did I do? I printed the number 1000. NDL means it goes to the next line. That's all. Entering into a new line, this will be clear when you see the programs. For now, just concentrate only on the loop. 1000 got printed. Here, 1000 divided by 10 means the number became 100. Now, 100 is greater than 0. See, out number 100 got printed. Number equals number by 1000 divided by 10. Number greater than 0. 10 greater than 0. True. Number equals number by 10. 10 by 10 is 1. Now again the loop came. 1 greater than 0. True or false? Absolutely true. See, out number 1 got printed. Number equal to number times 10. 1 tenth. 0. 0 is greater than 0. True or false? Yes, absolutely. It is false. So when it is false, the execution exits from the loop. Here, what difference did you notice between for and while? When you write a for loop, we immediately know the starting point and the ending point. As soon as we see this first line, okay, it starts from 1. I less than or equal to 10, I plus plus means I will keep incrementing. That means this loop will run 10 times. And just by looking at this line, we can decide that. As soon as we see this line, we will decide that this loop will run 10 times. But can we decide like that in a while loop? No. In a while loop, it depends on the logic written inside the body of the loop. In a for loop, just by looking at the first line, we can decide, okay, it will run 10 times, or else it will run 20 times, or 30 times. We know the starting point, ending point, and at what speed it will go. In such situations, a for loop is used. That is what we use. But when it comes to the while loop, as soon as we look at the logic, we can't decide how many times this program will repeat, right? What can we say about that? You have to debug. Debug means step by step, that is, the entire logic is here in these two lines. Sometimes there might be 100 lines here. Sometimes there might even be 200 lines, yeah? That means only when you understand how this entire body is executed, that is, what happens in each line, then you can decide how many times it will be executed. We can say that only then. Just by looking at this line, we can't decide. No one knows when the number will be greater than 0. In the sense, unless you know the logic inside this body, you won't know. Just by looking at this line, we can't tell. But in a for loop, if I equals 20, I less than 10, I plus plus, it runs from 0 to 9, which means it's decided for 10 times, done. But in a while loop, we can't decide like that. I perform multiple operations. I updated this number here once, but this number undergoes operations multiple times. I don't know when it will become 0. When I have to perform some operations, that's when we should use a while loop. But if I'm doing only one operation, like plus plus or minus minus, in situations where I am performing only a single line operation like this, we use a for loop. Now I'll show you the example I showed earlier. That is how it looks if you write a logic in a for loop and how the same logic looks if you write it in a while loop. I think question number 5 should be shown everywhere. Okay, let's see. Look here. What is our program? I am printing numbers from minus 11 to 20. See here, in the for loop, int I equals minus 11. N less than or equal to 22, n plus plus means what happens here is from minus 11 to 22, that is 11 plus 22. So the loop repeats 33 times. It's done. As soon as I see this one line, whether I printed something inside or not, I don't care about what I did inside. As soon as I see this line, I know that this loop will execute 33 times. It's done. But look here, int n equals 7. When not less than 22. I know that 11 is there. I know that the initialization is going up to 20. But am I going with plus plus 2 or not? Or can I write anything here as n equals 2? I can write anything here. Since it's n plus plus, this will also repeat 33 times. But now, suppose I write n equals to n plus 10 in n plus plus here. What happens to 11? Minus 11 plus 10, what happens? Minus 1. Minus 1 plus 10, 11. 11 plus 10 is 21. 21 plus 10 is 31. That means, see, it is printed 3 times. That means until I understand what is happening in this loop, I won't know how many times this loop repeats. But what happens inside the for loop is unnecessary for me. As soon as I see this line, I have already decided, okay, 33 times. It gets executed. So that's what I said. In a for loop, there are 3 parts: initialization, condition, and operation. In a while loop, there is only one condition. Why should I care what that number is? Why should I care up to where that number goes? If it is true, I will execute the loop body. If it is false, I will not execute it. That means you try writing every program using both for loop and while loop. Then you will clearly understand what loops are. There are 10 questions here. For these 10 questions, you don't need to write the entire logic. Just write the core part. Whatever you're understanding from the book, just write that core part. That will be enough for you. Just write this part. When we execute it, you can do everything. For now, just write whatever concept you have understood. You don't need things like IOStream, namespace, int main, return 0 and all that. Let's do those after we start executing the programs. You should write every assignment program in your book. That means you should write the answers in your book. Your notes until this introduction and until these basic problem patterns are done, your notes are your heart. Next, there is a do while. What do we call do while? We call it exit control. All these loops do the same work. They just do that work in their own style, that's all. Here, do while is also just like the while loop, only it goes based on the condition. But the only small difference is this is called exit control. Do while is called exit control, but while is called entry control. That means it checks the condition at the time of entry, but do while checks the condition at the time of exit. So suppose, for example, look at this program. Just imagine. What am I doing here? Number. Hello world. Here, the only difference in do while is this. Here, we write do. I have opened the block. When I closed this block, I wrote while here. That's it. Now simply, what's the difference between the code? Checking the ticket and then letting inside. Suppose your ticket is valid. Let's say we are going to a park or a movie. If they check your ticket and then let you inside, then it is while. Otherwise, just first go inside. Suppose they check your ticket when you're exiting. That is dual. Here the condition is not checked. Now whether the number is 0 or 100, all that is unnecessary. This number will be printed. After it is printed, the operation also gets executed. After the operation is done, then it checks if the number is less than 30 or not. Now, in a for loop or while loop, the condition is checked first, only then it gets executed. But here, it gets executed once anyway. The first time it will execute, it has nothing to do with the condition. For the next time to execute, then it checks the condition. Now, suppose the number is already, it's 40. Suppose the number is equal to 40. Here, 40 will get executed. After that, what happens? Number equals number plus 1. 40 plus 5, sorry, not number plus 1, it becomes number plus 545. Here, the condition is checked and it fails. If you play the animation, you'll understand. Number equals 20. So 0 has been printed. Number equals number plus 5. 5. Then, while number is less than or equal to 30. What is the number? 5 less than or equal to 30. True or false? Always true. Now what happens? Since it's true, that block will execute again, the do block. 5 got printed. Again, number equals number plus 5. 5 plus 5 is 10. Is 10 less than 30? True or false? Again, the do block will execute. Then will be printed. Because there we wrote 10 in the count statement. Next, number equals number plus 5. 10 plus 5 is how much? 15. Now it checks if 15 is less than or equal to 30. So So when it is true, what happens? It'll execute the do block again. Like this, it keeps happening. It becomes 20, then it becomes 25. So 30 plus 5, 35. Now 35 is less than or equal to 30. True or false? So now it'll exit. Did you understand what do while is? A simple while checks the condition and then executes the block. Do while is after executing the block, it checks the condition. Now this same program we, let's say in a equals to, suppose, just imagine, why I wrote a less than 15. That means this block will execute as long as it is less than 15. Now see, a has 20, 20 less than 15, true or false? Immediately it's false, so it won't execute. That means in this block executes 0 times. Because the condition failed right at the beginning, it won't execute. Now let's say we take the same thing with do while, same program. A equals 20. Now here I wrote some lines of code. While less than 15. Suppose I wrote it like this. It'll execute once. This executes 0 times. That is the difference. This one executes first. Then it checked whether A is less than or equal to 15 or not. But while checked whether A is less than 15 or not. After that, see, the block gets executed. To put it simply, we use some ATM machines. In some ATM machines, what happens is immediately at the start, they will ask to enter the PIN. Now, let's say the PIN number is correct. Then it gives you options: withdraw, check my balance, and multiple other options. Suppose there are some ATMs like this. What do you want? Do you want to check your balance? Do you want to withdraw? If you want to withdraw, how much do you want? You want 1000? Okay, now enter your PIN. All these operations are now complete. We've entered the PIN. Now, whether the PIN is right or wrong, suppose the PIN is wrong. Sorry, when it is wrong, it says so. Suppose here itself, it will say PIN is wrong. Up to here, it won't proceed, understood? So, machines designed like this were used while operating. Machines designed like this first do this, then check why. After that, check the condition. See here in our option, after all the operations are done, at the end the condition is checked. Here, first the condition is checked and only then it is taken to the operations. That is the only difference when we are at the beginner stage. The most important question is the difference between while and do while. One is entry control, meaning the control is at the point where it enters. The other is exit control, where the control is at the exit point. This is entry control, that is exit control. These are the loops. In this, you have another concept in loops. First, you just write the loops. So, when your actual program starts, I will tell you. In loops, there is a weak condition. What is this weak condition? For example, for. Now, see, I. For loop prayer. Here, I equals 10. E greater than 5. Suppose I wrote I plus plus like this. What happens in step 1? I 10. 10 greater than 5. Next 11 greater than 5. Next 12 greater than 5. Next 13 greater than 5. 14 greater than 5. 15 greater than 5. Will this program ever end anywhere at all? See, here I have put 10, but here I wrote I greater than 5. Suppose if I do I minus minus here, one might think so. But there I did I plus plus. That means 10 will keep incrementing. That is I forever. Forever, I greater than 5 will always be true. So the for loop will keep running forever. So this is what is called an infinite loop. So why does this infinite loop occur? It's just because of your weak condition, meaning when your condition has no relation to the operations you are performing. So what happens in such a case is this. It gets stuck. The program, depending on the software you're using, sometimes gets stuck. Some software will get stuck. In some cases, after running out of memory, the program will stop. But what happens here is the program just stops when it goes into an infinite loop. That means it gets stuck. That's what it is. Suppose you wrote the same thing in a while loop like int a equals 10, while a is greater than 5. Here I did 4 operations. I did a plus plus. I did a equals a into 2. Next. Again, I did a equals a plus 5. Like this, I did multiple operations because inside the while loop, you can write as many as you want. So I performed many operations and now okay. Now a is always greater than 5, right? Here I incremented it. Here I incremented it. Here I incremented it. Here I did into 2 increment. Here I did plus 5 increment. This is also a weak condition. That means these are infinite loops. If we write a program where the operation and the condition are not related, that program will keep executing forever. Your program will keep executing until it gets stuck. This is called an infinite loop. So these infinite loops will occur sometimes when you're practicing programs, you'll come across them then and you can find out. So today's class is about for loop, while and do while. Here I have printed 10 as an example, but you can use any condition you like. I have given 10 programs here. Execute as many programs as you can. By the time you finish this class, you might have 20 or even 30 programs. Depending on your coding and maximum membership, there is a chance that the questions here might change. So at present, while I am teaching the class, there are 10 questions. You can practice all the ones given here. This is a look. Prepare your own notes on these control statements and loops. The better you understand these two concepts, control statements and iterate statements, the better your coding will be. About 30% of coding is covered in this itself. So, complete these. We'll meet in the next class. Thank you. Happy coding.